Hello dear students, this is your Engineering Mathematics 3 lecture. Today's topic is normal probability distribution. This topic is from 4th unit, probability and probability distribution. Already we have discussed binomial distribution and Poisson distribution. Now here we are going to discuss about normal probability distribution. Normal distribution is a continuous distribution. It can be derived from the binomial distribution in the limiting case when n, the number of trials is very large, and p, the probability of success is close to 1/2. The probability of success is close to 0.5. The general equation of the normal distribution is here. It is given by y is equal to f of x is equal to 1 upon sigma into under root 2 pi into e to the power minus half in bracket x minus mu upon sigma whole square. Here, sigma is standard deviation and mu means the mean. It is the notation of mean. See, where the variable x assumes all values from minus infinity to infinity and sigma, called the parameters of the distribution respectively. They are known as mean and standard deviation of the distribution, and that mu lies between minus infinity to infinity and sigma is greater than 0. X is called the normal variable or variate, and f of x is probability density function of the normal distribution. See, what is x? It is called the normal variable, and f of x is probability density function of the normal distribution. See the graph. The graph of the normal distribution is called the normal curve. This is the normal curve. It is bell-shaped and it is symmetrical about the mean mu. That curve is symmetrical about the mean mu, as shown in this figure. The two tails of the curve extend to infinity. These two tails extend to infinity. That two ends do not touch the x-axis. That two tails of the curve extend to plus infinity and minus infinity, plus infinity and minus infinity towards the positive and negative directions of the x-axis respectively. And they gradually approach the x-axis without ever meeting it. The line x is equal to mu. This line is x is equal to mu, divides the area under the normal curve above x-axis into two equal parts. This curve x is equal to mu. This curve divides the normal curve in this line x is equal to mu, divides the normal curve into two equal parts above the x-axis. The area under the normal curve between any two given ordinates x1 and x2 represents the probability of the values falling into the given interval. The area between these two ordinates x1 and x2, this shaded portion, this area represents the probability between these two ordinates x1 and x2. The total area under the normal curve above the x-axis is 1. This total area under this normal curve, its value is equal to 1, because here in normal distribution, area is connected to probability. So definitely the complete area of the normal curve, it is equal to 1, because the maximum value of probability is also 1. So this total area is 1 here. That is integration minus infinity to infinity f of x dx is, its value is 1. And thus probability between x1 and x2 is equal to integration over x1 x2 f of x dx. This is the value, because here probability is connected with area under the curve. This is a beautiful relation developed by the normal distribution. It is also equal to integration over x1 x2 1 upon, you know, the value of f of x. F of x is this value, probability. General equation of normal distribution. So you know the value of f of x. F of x is this equation, and if you put here the value of this f of x, this integration, it reduces, it becomes like this. Okay. Now standard form of the normal distribution. Okay. Standard form. What is standard form of normal distribution? If x is a normal random variable with mean mu and standard deviation sigma, then the random variable z is equal to x minus mu upon sigma has the normal distribution with mean 0 and standard deviation 1, and the random variable z is called the standard normal random variable. See, we are going to introduce here the standard normal variable. How it is introduced here? See, if x is, you know that if x is here, x is a normal random variable with mu is the mean and standard deviation is sigma. Then the random variable here z, which we have introduced here, a new random variable z, which is equal to x minus mu upon sigma. It has the normal distribution with its mean is 0 and standard deviation is 1. Then the random variable z, this random variable z is called the standard normal random variable. Thus, the probability density function or the normal distribution in standard form is given by f of z is equal to, now we have converted x in terms of z. So your function is now f of z, not f of x. In place of f of x, now it is f of z is equal to 1 upon under root 2 pi. Why it is like this? See, this is the general equation of the normal distribution given by. Now we have converted x in terms of z. So your function is here f of z is equal to 1 upon sigma. When we introduce z, in that case standard normal variable, then the value of standard deviation is 1. So this sigma, its value is 1. And again the value of mu is 0, mean is 0, written here. So this equation, it reduces to, or it becomes 1 upon under root 2 pi into e to the power minus half z square. Okay, that we replace x by z, mu is 0, sigma is 1. So this is the equation of the normal distribution in standard form, and z lies between minus infinity to infinity. Now this function is, this equation is free from any parameter, means it is free from mean and that's standard deviation. This is useful to compute areas under the normal probability curve by making use of standard tables. Using standard tables, you can calculate the area, which is nothing but the probability of the normal curve. So under the area under the normal curve, the area under the normal curve is divided into two equal parts by z is equal to 0. Now we introduce here z, the standard normal variable. Then the curve will be, that normal distribution curve will be like this here. And in this diagram, z is equal to 0. That area under the normal curve is divided into two equal parts by z is equal to 0. This line is nothing but z is equal to 0, mean is equal to 0. And it divides the normal curve into two equal parts, the left hand side area and right hand side area. Z is equal to 0 to 0.5. Because of the z is equal to 0, that normal curve is divided into two equal parts. The half region is 0.5 and the next half region is 0.5. Okay. Now the property, area property, that first one, probability between z1 and z2 is equal to, when we have to find out the probability between x1 and x2 using normal distribution, then we convert x1 and x2 in terms of z1, z2, and then we find the area, find the probability between z1 and z2. Now see, what is the formula to calculate the probability between z1 and z2? It is equal to, if z1 and z2 both are positive, then the curve, that diagram will be like this. When z1 and z2 are positive, then they will be in RHS side, and then the probability between z1 and z2 is nothing but the area between z1 and z2. Now this complete area is of z2 and this area is of z1. So if we subtract the area of z2 minus area of z1, then we have the probability between z1 and z2, because area is connected to probability. So the formula to calculate the probability between z1 and z2 is equal to area between z2 minus z1. The maximum area is of z2 minus area of z1. It is equal to probability between z1 and z2. This is only when z1 and z2 both are positive. Okay. The next is probability of z is greater than z1. Probability when z is greater than z1. See, this is the curve. this is Z1. Z1 is positive. Suppose Z1 is positive, then Z1 will be here in RHS side. Okay. Now you have to find out probability when Z is greater than Z1, means this shaded portion. We want the probability of this shaded portion, because we want the probability of Z when it is greater than Z1. So calculate the probability of this shaded portion. So it is nothing but the area of RHS side, which is equal to 0.5 minus area of Z1. So the formula is 0.5 minus area of Z1. If we subtract this area of this RHS side, we have the value of area of this shaded portion. And this is nothing but the probability when Z is greater than Z1. So this is the formula. Now the third one is when Z is less than minus Z1. Means when your Z1 is negative minus Z1, then it will be in LHS side. This is the line for minus Z1. And we want Z less than minus Z. This is the shaded portion. Shaded portion area is, or we want the probability of this shaded portion because Z is less than minus Z1. Now how to calculate this probability? Now this LHS side complete region is of 0.5. And you subtract the area of Z1. Area of Z1 is this blank region. If we subtract this region from 0.5, we have the area of shaded portion. And the area of shaded portion is nothing but the probability of Z less than minus Z1. So the formula is 0.5 minus area of Z1. Okay. Now the next is find the probability between minus Z1 and minus Z2. Means both Z1 and Z2 both are negative, then they both will be in LHS side of the curve, Z1 minus Z1 and Z2. Now find the probability between these two. Means both are negative. So the probability between these two is this shaded portion. So you calculate the area of this shaded portion. That will be the probability between Z1 and Z2. So how to calculate the area of this shaded portion? Area of Z1. This area of Z1 is a big portion minus area of Z2. Area of Z2 is this blank portion of in here LHS side. So the formula is area of Z1 minus area of Z2. That will give you the probability between minus Z1 and minus Z2. So both are negative. So both lie on LHS side. So subtract the area between these two. The last one is find the probability between minus Z1 and minus Z2. Sorry, here it is plus Z2. Z2 is positive. So make a correction here. This is positive. Here the area the find the probability between minus Z1 and plus Z2. Means Z1 is negative, so it will be in normal curve, it will be in LHS side, and plus Z2 will be in RHS side. Now you find the probability between minus Z1 and Z2. So how to calculate the area between minus Z1 and Z2? You just do the addition of area of Z1 plus area of Z2. That will be the shaded portion. And that shaded portion is nothing but the probability between minus Z1 and Z2. So you just do the addition of areas, area of Z1 plus area of Z2. So this is the formula to find the probability between minus Z1 and plus Z2. Now how to calculate the area? This is the table, like the logarithmic table, or this is the table to find the area of normal curve. These are the values of Z, and using the values of Z, from the values of Z, you can find the area for the value of Z. Now here is one instruction. In each row and each column, 0.5 to be subtracted. When you find the area, you every time subtract 0.5 from that area. That will be your correct answer. Okay. Now next. Next example. We are going to solve the example. Assuming that the diagram of 1000 brass plugs taken consecutively from machine form a normal distribution with mean 0.7515 centimeter and standard deviation 0.0020 centimeter. How many of the plugs are likely to be approved if the acceptable diagram is 0.752 plus minus 0.004 centimeter? What is the example? Assuming that the diagram of 1000 brass plugs taken consecutively from machine form a normal distribution. Means it is clear here that it is the example of normal distribution. With mean is here, mu is equal to 0.7515 centimeter and standard deviation is given 0.0020 centimeters. So write down in solution. Now, how many of the plugs are likely to be approved if the acceptable diagram is 0.752 plus minus 0.004 centimeter? Means in this diameter here 0.752, you at once add 0.004 centimeter and at once you subtract 0.004. So you will get the values of x1 and x2. See what is x1? 0.752 plus 0.004 is equal to 0.756 centimeter. What is that x2? You subtract this 0.004 from 0.752. And so the calculated value is 0.748 centimeter. So these are the values of x1 and x2. Now from x1 and x2, you find z1 and z2. You convert x1, x2 in terms of z1, z2. So z1 is x1 minus mu upon sigma and z2 is x2 minus mu upon sigma. Here you put the values of x1 mu and sigma, x2 mu out sigma. Simplify and calculate. Z1 is 2.25 and Z2 is minus 1.75. Now we want how many of the plugs are likely to be approved if the acceptable diagram is find the probability. It means that find the probability between x2 and x1. Here x2 is small and x1 is a large value. So you find the probability between x2 and x1. Now, how to find the probability between x1 and x2? First, convert x1, x2 in terms of z1, z2. Here we have converted that x1, x2 in terms of z1, z2 using the relation. Now, after finding z1, z2, you find the probability between z1 and z2. Now, what is your z2? Z2 is 0.748. Now, sorry, Z2 is minus 1.75. Now, what is the area of 1.75? That is the question. And then see probability between z1 and z2. Now that z1 is positive and z2 is its value is negative. You see the diagram. Z2 is negative minus 1.75 is here in LHS side and z1 is positive, so it lies in RHS of the normal curve 2.25. Okay. Now we want the probability between z1 and z2. Means you find the area between z1 and z2. Because area is connected to probability. Now, what is the area between Z1 and Z2? This shaded portion is the area between Z1 and Z2. Now, what is the area of Z1 and what is the area? Means you just add the area of Z1 plus area of Z2. That will be the probability between Z1 and Z2. Now, question is what is the area of Z2? Now, what is Z2 here? The value of Z2 is minus 1.75. You see the distribution table, normal distribution table, 1.75. This is 1.7 and 5, the difference of 5, you see the difference of 5 here, 1.75. This is 1.7 and see the difference of 5, 0.05 here in this column, 0.05, 1.7 and the difference is of 0.05. So it is 0.9599. This is your area, 0. See what is your area here? This is 0.9555. This is your area of 1.75. Now subtract 0.5 from this value 0.9599, because here it is mentioned in the table, it is mentioned that in each row and column you subtract 0.5. So subtract 0.5. If we subtract 0.5 from that value, then we have the area. We have the area here 0.4599 plus area of Z1. What is Z1? Z1 is 2.25. You again take the value of area 2.25 from the distribution table. 2.2. You see in the result 2.2. The 2.25. The difference is of 5. So 2.25. This is 0.9878. 0.9878 is the area. 0.9, 2.2. In the row 2.2. Sorry, 2.7. 2.75. 0.9970. This is the area. Subtract 0.5 from that area, so you will get the area 0.487. Sorry, it is 2.75, not 2.75, it is 2.25. 2.25. 2.25. 0.9878. 0.9878. Subtract 0.5 from this area, 0.9878, and so the area is here 0.4878, and you just add these two areas, that will be your answer 0.9477. So number of plugs, this is the probability between x1 and x2. It means the probability between z1 and z2, because we have converted x1 x2 in terms of z1 z2, and we have calculated the area between z1 and z2. It is nothing but the probability between x1 and x2, and it is 0.9477. Now this is the probability between x1 and x2. Now we want our aim is how many of the plugs are likely to be approved if the acceptable diagram is, means assuming that the diagram of 1000 brass plugs, out of 1000 brass plugs taken consecutively, how many plugs are likely to be approved? That is our question. So out of 1000, so multiply this probability by 1000, so that we have the number of plugs likely to be approved, and it is equal to 947.7. 947.7 means approximately it is 948. So 948 plugs are likely to be approved. This is your answer. And this example is over here. And so today's session is over here. Thank you.